In this video, we're going to have a look at doing some trigonometry in non-right angled triangles. In particular, we're going to have to look at the sine rule and how we find a side. But before we actually find a side, I'm going to show you how or where the actual rule comes from. And if you're doing general or standard mathematics, then you won't really need to worry about where it actually comes from, the development of the rule. So you can fast forward through this part and then actually go through the use of the rule and the examples. So let's work through them. So we can use trigonometry in triangles that are not right angled. So up until now, we've been using just right angled triangles. So for instance, here's a triangle that's not right angled. So none of the angles in here are 90 degrees. And what we're going to do, first of all, is label the triangle. And we label them with capital letters. We should be used to this from back in year 7 or even back in primary school. And we'll start off with this vertex A, and this side opposite, we're going to label that lowercase a or little a if you like. And we'll do the same with vertex B, the side opposite, we'll call it lowercase b or little b. And we'll do the same with C as well. So we'll get to lowercase c. So what we've now done is we've just labelled the three sides in our triangle. So let's continue. So what I'm going to now do is from one of the points, and we'll use the point C, I'm going to drop a perpendicular height in here, and it's going to meet this point down at the point D. And I'm just going to call this the height, as I said. And what we're going to do is use some right angle trig and find something about the height of this particular triangle. So the first thing we're going to do is have a look in this triangle here, ACD. So to make things a bit easier, I'm going to cover up this part of the diagram. So that way we can just see our triangle here. There's our height. And I'm going to use some right angle trig and have a look at what the sine of this angle is. So the sine of this angle, remember, is opposite over hypotenuse. So our opposite is h and our hypotenuse is b. So we're going to have the sine of this angle is h over b. And we can rearrange that. So we don't like fractions in there. So let's get rid of that fraction by multiplying both sides by that denominator. And we get the height is b times sine alpha. So that's what we've done in that triangle. So there's our original triangle back together. And what we're now going to have a look at is in triangle BCD. So let's cover up the other part of the diagram. So there's our height still. We're going to look at this angle here and use some right angle trig. So we're going to find the sine of this angle, which again is opposite over hypotenuse. Just being careful what we've labelled them. So our opposite is h and our hypotenuse is a. So let's substitute those in. There we go. So sine b is our opposite over hypotenuse. And again, we don't want these fractions in the denominator, so let's multiply both sides by a to get rid of that. And we get a sine beta equals h. So let's put the two together then. So in triangle BCD, so this triangle here that we just worked with, and the first triangle, we both found that h, the height, was a sine beta and also b sine a. So if those two are the same height, then these two must be equal. So let's have a look what happens when they're both equal. So we've got a sine b equals b sine a. So what we'll do is we'll rearrange this. So let's divide both sides by sine b. That eliminates on the left hand side, and we've got it as a fraction on the right hand side when we divide it. And then what we'll also do is divide both sides by sine a, so it eliminates on the right hand side and ends up over here on the left hand side. So we get a over sine a equals b over sine b. And that's a really important thing. That's part of our rule. And we're going to use that very often when we're using the sine rule. So that's where part of the sine rule comes from. But what we could also do is I could have a point D here and have its perpendicular height there, and then go and find something in relation to this angle and the height. And when we do that, we also find that we get C over sine C also ends up being the same. So this is the sine rule. You'll notice that there's three parts, two equal signs. We only need two parts of it to work. So to use the sine rule, we're going to use two sides and their two opposite angles. Okay, so now we're going to have a look at an example on how we use the sine rule. So in this example, we're going to find the value of k, correct to one decimal place. So let's work through it. As I said, we only need the two parts. We have two sides and we have their opposite angles. So the two sides and their opposite angles. So we need to make sure we recognize this. Sure, we don't know what one of the sides are. We're trying to find it, but we're using two sides and their two opposite angles. So let's substitute in what we know. We're trying to find k and it's opposite the angle of 47 degrees. So we'll substitute those in. The k, and it was opposite the 47 degrees. So k over sine 47. The next part we need to look at is the other side, and it's opposite the 102 degrees. So let's substitute those part into this side of the rule. And we get k over sine 47 equals 5.2 over sine 102 degrees. We're trying to find out what k is, so we want k by itself. Now this looks complicated, but this is just a number. So the opposite of dividing by sine 47, we can multiply both sides by sine 47 to eliminate that. And when we do that, the sine 47 comes up into the numerator. And this is now just a straight calculation on our calculator. When we're doing that and pressing it in, if you've got the Casio, make sure you close the brackets after the signs. So after you put the angles in, you don't need to press the degrees button. Okay, so we're going to do 5.2 sine 47 close brackets because it will automatically put an open brackets there. And when we do that, we get k is 3.888001408. So what you need to do is practice that and make sure you get that on your calculator. But don't forget, we want it correct to one decimal place, so remember how we round those off. We have been doing those for quite a number of years now. So k is approximately equal to 3.9 centimetres. So that's how we find a side using the sine rule. And remember, this was not a right angled triangle, so we could use the sine rule there. So let's have a look at another example. We want to find the value of v, correct to three significant figures, and I'll show you that in just a moment. Again, we're using two sides and two angles, but you'll notice that the angle opposite v is this one here, and it's missing. So what do we know about a triangle? Well, we know that that angle there is missing. We're going to find that. So what angle plus 29 plus 110 equals 180? Because remember, the angle sum of a triangle is 180 degrees. And then we find that that missing angle is 41 degrees. So we have to do a little bit of working first before we can actually go and use the sine rule. So let's go and put that 41 degrees in there, make it a bit easier for us when we're doing our substitution. All right, so let's do it. We're trying to find v, and it's opposite the 41. Substitute that in, and the other side we're using is the 8, and it's opposite the 110. So we'll substitute that in. So the angle we didn't use this time was the 29 in our substitution, but we did use it to help us find the 41 degrees. So be careful with these type of triangles. And again, multiply both sides by sine 41 to get v by itself. And then we use our calculator and write the whole thing down. And now we reread the question and we want it to three significant figures. And in case you've forgotten how to do significant figures, I'll go through it anyway. So from the first non-zero digit on the left, that's our first significant figure. If there were zeros in front, they're not significant. So it's only the first non-zero digit is significant. So there's 1, 2, 3. And what I do is I put a line down there so I know that there's my 3 significant figures. But we just check the next one in case it's a large digit. And we should know by now that 5 is a large digit. So we actually say that 5.58 is actually closer to 5.89. So what we've just done is said that V was approximately 5.89 meters. So we've now just learned how to use the sine rule. They're the basics of them. So what you now need to do to get better is to practice, and then practice again, and then practice some more. And the more that you practice, the easier it is going to become. So I hope you have found this video useful for you, and that you will find that finding the side using the sine rule is quite easy once you practice them quite regularly. Thanks for watching.